Alright, there was a request for 11 and 12 on worksheet 10. So with these you had to write the equation in terms of cosine. So a couple things. So first of all, I would maybe try to draw a picture if you need to. This one says it has a local maximum up at 5 and a local minimum down at 1. So this one's probably easy to kind of figure out where the middle is. Middle of that would be at y equals 3. So there's a vertical shift of 3. Another way you could do that is you could just say, okay, I'm going to find the average. So take 5 plus 1 is 6. Divide by 2, you get 3. So 3 is right in the middle, the average. Then the other piece you can get from here is what's the amplitude. So the amplitude is whatever the distance is. So 5 minus 1 is 4. But then you cut that in half and you get 2. So I know it's going to go from y equals 3. It's going to go up 2, down 2. So I know the amplitude is 2. Alright, so then down here, this information, it says the period. Well, if the period is pi over 3, I can set that equal to 2 pi over b, and I can solve for b. So when I solve for b, I cross multiply. b times pi equals 6 pi. When I divide by pi, I get b is 6. Alright, so I've got a b value of 6. And the other piece of information for the phase shift tells me I have a local minimum. So what I would do is let this be the phase shift. So the phase shift, remember, is the opposite of c over b. So I would set negative pi over 2 equal to negative c over 6. Again, I would cross multiply. Put this negative with something. I'll put it with the negative with the pi. So I get negative 6 pi equals negative 2c. Divide by negative 2. And I get 3 pi is c. Alright, so then when I go to put it together, because this was a minimum, that means it's going to start over here with a minimum. Well, actually over here, it'll be down here, with a minimum and then go up and come back down. So when I do a phase shift of negative pi over 2, I'm just going to make sure then I put a negative in front of the a value so that it flips, it starts at a negative. So my equation is going to be y equals negative 2, because my amplitude was 2, remember? But I put the negative so it starts at a minimum. Negative 2 cosine of b was 6x plus my c value of 3 pi. And then I had a vertical shift of 3. So there's my equation. Okay, so the minimum with cosine, if it's a minimum, just put a negative in front of it and then do your phase shift and your period, find b and c. This information up here gave me my amplitude and my vertical shift. For number 12, now they give you intercepts. So the intercepts are at 1/3, 1, and 5/3. So if it's cosine, and those are the intercepts, they're coming this way, there's one at 1, there's one at 2, at 5/3. So what that tells you is the period. The period goes from here to here, because remember there's an intercept halfway in between. So, and again, this kind of looks like sine, we're dealing with intercepts, but realize the cosine will just be, when we shift it, will be what that is. So all this is saying is that I have intercepts here, you've got your cosine curve. If these are the intercepts, then I know that the period has to be 5/3 minus 1/3 or 4/3. So the period of that is 4/3. That's what that's telling you. Okay, there's a local minimum at x equals 0. So now I know when I go to graph it, at 0, there's going to be a minimum. It's going to come up through 1/3, down back through 1, and then back up at 5/3. So those are my intercepts, 1/3, 5/3. So I still know my period is 4/3, but it's starting a minimum here. So I don't need to do a phase shift then. If I'm going to start with a minimum here, I don't have any phase shift. My amplitude they told me was 2. I know the period, so if the period is 4/3, I have to set that equal to 2 pi over b. So if I cross multiply, 4b has to equal 6 pi. So b is going to equal 6 divided by 4 would be 3/2 pi. Alright, so my equation, y equals, again I started down here, so negative, amplitude was 2, cosine of, my b value is 3 pi over 2x. And there was no phase shift. So there's my E equation. Alright, let me hop to worksheet 11. Worksheet 11, you asked for number 5. With number 5, it says, this was your equation. You had to figure out period and phase shift to graph it. Again, we don't have an amplitude, but remember the cosine is stretched by 4. With this one, this is already factored out. So really it's 1/4. You could think of this as 1/4 times x minus 1. So your b value is 1/4. Your c value technically is negative 1/4. But if it's already factored, this now tells me that it's shifted 1 to the right. So the phase shift is 1. For the period, if you set 2 pi over b, which is 1/4, 2 pi over 1/4, to equal your period, if you take 2 pi divided by 1/4, it's like multiplying by 4, you get a period of 8 pi. So you get a period of 8 pi and a phase shift of 1. It's a secant, so the first thing you're going to do is graph the cosine. So when you go to graph the cosine lightly, it has a phase shift of 1, so you're going to start 1 over. That's where the maximum will be. And the period is 8 pi, so when you draw this in, this happens at 8 pi plus 1. I'll do 1 plus 8 pi. So it was at 1. I'm going to add 8 pi to it. The minimum will occur at 1 plus 4 pi. Halfway here, the intercepts will be at 1 plus 2 pi and 1 plus 6 pi. So to graph the secant, anywhere where you see an intercept, you're going to draw in an asymptote. So the asymptotes are at 1 plus 6 pi, 1 plus 2 pi, 1 minus 2 pi. I was at 1, I just subtracted 2 pi to get to here. And then all I need to do, and this was at 4 and negative 4. And now I just need to flip these. This comes down and touches that graph and goes back up. Here's the minimum here, it touches there. And there's one period, this and this. And again, just make sure this is lighter, or you could dot it in something so I know that that's just the, helps you find the secant. But the secant is actually these two curves right here. Alright, and then the last two was on worksheet number 12. This one was a little tricky because I wasn't quite sure. I think I should have given you one more piece. So let's say I gave you that this was 5 pi over 3. So I just assumed that these two distances from here, these two tick marks, it was the same distance. So if this was 5 pi over 6, that was a sixth of a pi here. So I went from 3 halves pi, negative 3 halves pi, and went pi over 6 that way. So I assume, that's what I assumed. Some of you assume that the intercept was here, but it doesn't really look like it crosses at negative pi over 2. So once you get that assumption in, you, again, look at what the period is. If those two things are equal, I just went from pi to 3 halves pi. So I said the period was 2.5 pi, 2.5 pies. Okay, so there's 1 pi to here, 2 pies, 2.5 pies was the period. The phase shift then would be, no matter how you looked at it, 5 pi over 6 from this piece of information. So then when you solve for b, you'd say, okay, pi over b, don't forget, because now the period is pi. Pi over b equals 2.5 pi. So pi equals 2.5 pi times b. So the pi's cancel. B is going to equal 1 over 2.5, which if you want to put that as a fraction, you could. I just put it as 0.4. You could write it as 4/10 or 2/5 if you wanted. And then to find c, your phase shift, 5 pi over 6, equals the opposite of c over b. Again, if you cross multiply, I got negative 6c equals 0.4 times 5 pi. I'll use my calculator. I guess I probably used my calculator. It came out, I think I put that as a fraction. It was a little bit easier if I didn't have a calculator. And I got negative 1/3. Alright, so there's B, there's C. So now, when I find my equation, y equals cotangent 0.4x minus 1/3. With this one, real quick, the period was 4, the phase shift was 1, so that's where I got my equation, y equals 3 sine of pi over 2x minus pi over 2. I put a phase shift of 1 right there.